Welcome. We'll continue with the discussion on how to design different systems in Matlab. In this, let's take an Simulink. In this, let's take an example of an AM modulation. How do we do AM modulation in Simulink? All right. Now we know the AM equation with message signal. Suppose is mt, that is the message signal, is AM sine omega mt, where AM is the amplitude of the message signal, omega m is the frequency of the message signal in radians per second. Same way, CT is the carrier signal, and this is amplitude of this carrier is AC, and frequency is omega c in radians per second. Then we know the equation of the AM, standard AM, is this AC 1 plus mu sine omega mt cos omega ct. Now, how do I design this system in Matlab? So, remembering this equation, have a look at this equation, close look at this equation. Then we are going to build this system, this AM system in Matlab. All right, let me switch to Simulink. Let's switch to Simulink. Where is my Matlab? Where is the Matlab? Why isn't my Matlab visible here? Let me, no. Okay, this is, let me, so this is, let me switch back. This is the Matlab. And let me open Simulink. Clicking on the Simulink tab, you will have a window that looks like this. Then clicking on the library browser. Then what do I require? First of all, I require sine view. And this sine view, yes, right? I require, what do I require? I require, sorry, this is should be cone. This should be sine. Huh? This should not be cone. This should be sine. So I require two sine waves and one summer and one gain block. That's it. This is the gain. This is the summer, and I require one multiplier. Also, this is the multiplier. All right. Let me switch back to Simulink. This is my Simulink. Click on library browser. And then this is the library browser. And then getting the blocks. So I require a gain block. I require a product block. Where is the product? Product is not given in this. Sum is here. This is the product block. So this is the product block. This is the scope to view the results. And I require sources. I require sine wave. So I require two sine wave blocks. And let me switch back to the model. So this is the model. So this is sine wave. So let's call it message. Let's change the name and let's type it as message signal. MSG and message wave. And this is the carrier signal. And let's suppose the amplitude of this frequency, let's take it equal to 2 pi for simplicity. Let's take it 2 pi. Can change it to any value. So this is 2 pi. And then double clicking on this carrier wave, and let's suppose the amplitude is 5. Frequency is, let's suppose, is 2 pi. This is in radians, please remember that. So the frequency is actually 25 only. So apply and click back on the model. This is the model. So this is the scope. This is the product block. This is the summer. And this is the gain block. And the gain is mu. So let's call it mu. And then let's pass it to this. And the input is one more block constant. There is one constant there. If you see the equation, there's also one here. So I need a constant block. So let me switch back to this. library browser, get the sources. This is the constant. Add to the model, switch to the block. So this is the constant one. This one is from standard AM equation. This is this. And then what we are going to do, we are going to multiply this carrier signal with whatever is 1 plus mu sine omega t. So that's what we are doing. This is 1 plus mu sine omega t. Then we see the result by connecting the scope, but before we connect to the scope, we'll change the input to 3. So now this scope has 3 inputs. We want to view the message. This is the message signal. This is the carrier signal. Finally, we want to see the standard AM. So this is message, message signal. And this is the carrier signal, and this is the AM signal or AM wave. All right, let me run this and show you the result. Let me run this and show you the result. So this is the result. Now it is, I can use separately. Let me change the layout. You can see the layout of this. So this is the original message signal whose amplitude is whose amplitude varies from -1 to 1. This is the carrier, its amplitude varies from -5 to 5, and this is the AM signal. Now let me go back and change the value of mu. Here mu is 1. You can see mu is 1. Now let me change it to 0.5. Let us change it to 0.5. Let me change it to 0.5 to show you. Change the value to 0.5. Okay, then you can see the result by clicking on this. You can now have a look at the waveform that we obtained. So this is our AM when mu is 0.5. Now let me change the mu again. Let me change the mu again to 0.2. Let's change it to 0.3 rather. And you can see I have changed the value to 0.3. This is the 0.3, and now let me run this model again. You can see the result. This is the AM wave when mu is 0.3. So this is the message, this is the carrier, and this is the AM wave. So this is how you obtain this AM signaling. This Simulink. By the way, you don't need to do it in Matlab. You don't need to do it because there is already AM block available to you. You don't need to do any communication because everything is built already there. Now let me show you this. Click on the communication toolbox. You can see there are modulations. Analog baseband modulations. You can see there is FM broadcast. There is analog passband. There is different AM, DSB AM, modulator passband. These are already available to you. And there are also digital modulations, AM, this APM, CPM, FM, OFDM, different depending upon the version of the Matlab. You have different these communication modulation formats available to you. So you don't need to build it. But this was just an example to show you how you can build any system. So this is simple AM. You can build any system in Matlab. In the next session, we'll see how to build an FM modulation in Matlab in this Simulink. All right, let me end this session here. In the next session, we'll learn how to do the FM.